a couple of things that will look new, but conceptually speaking, they are not new, and they actually make perfect sense. So everybody's okay with this? Yeah? Oh, because I haven't turned on the screen, because sometimes I'm an idiot. Excuse me. Okay, so we got down to these two terms, an entire radical and a mixed radical. That's where we got to. An entire radical is this: symbol, radicand, no coefficient. A mixed radical is one of these: coefficient, radical sign, radicand. All right? And this A is all the factors we removed from the radicand. And since they are factors, what do we do with them once we remove them, if there's more than one? What math deals with factors? Multiplication. All the factors we removed from the radicand multiplied together. So everybody should remember all of that from the 10th grade. You may not remember the words, but you should remember the process, yeah? Okay, so let's move it along from there. We are going to take root 72 and we are going to convert it to the lowest terms mixed radical. So there's two ways to do this. There's a longer way that is easy and always works, and there's a shorter way that requires you to memorize some stuff. I, of course, am going to show you both of those ways. The ways you were taught at the beginning of the 10th grade would have been this. You take root 72 and you break it down into factors using that thing that you learned in grade 4 from Mrs. Bad Crumble, the factor tree. So you break 72 down into any two of its factors. So what are two factors of 72? 8 and 9. And because 8 and 9 are not prime numbers, we continue to break them down again. Do I need to review what a prime number is for everyone? No? Good. So we're going to break it down again. What are two factors of 8? 4 and 2. So there's 2 and 4. Now, is 2 a prime number? Yes, so we would stop. Anytime we get to a prime number, we end the branch. Is 4 a prime number? No, so we break it down. 2 and 2. All prime numbers. Good? And 9 is what? 3 and 3. Are they prime numbers? Yes. So all of you should be aware of the fact that the square root of 72 is also the square root of 2 cubed times 3 squared. Everybody cool with that? Because 2 cubed is 8, 3 squared is 9. Is everybody good? Now, what should our index here be? But we never write this particular one. It should be a 2, which means I am looking for groups of 2 factors, yes? So how many 2's are under there? There's 3 2's under there. I need 2 of them, right? So I bring out one group of 2. How many 3's are under there? 2. I need 2 of them, so I bring out a 3. Everybody with me? And what did I leave under there? A single 2. Now I have factors out here to make the coefficient. What do I do with those 2 factors? Multiply them together to get 6 root 2. Is everybody cool? Easy peasy, right? That's the easy way. That's the way that always works, no matter what. Now there's also a shortcut. Since this is the root of 72, the index is 2, yes? So this is asking for the square root of 72. I'm allowed to break 72 down into smaller chunks, yes? So if I can remember a square root that is a factor of 72, I can make this go much faster. And I know that 72 is 36 times 2. Yes? Does 36 have a square root? 6. So I bring out the 6, and I leave in there a 2. And it will show up in a moment. And you can see that they are the same answer. I just wrote the index there. Is everybody cool? So if you know your square roots up to about 20, this becomes really, really easy to do. And I warned you in the 10th grade, if you were in my class, you should memorize the first 20, right? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, up to 20, which is 400. It's really, really helpful. It's not needed, but it's really, really helpful. Okay? So let's have a look at this next one, the square root of 99. Can you think of a perfect square that is a factor of 99? 9. Right, it is 9. So isn't the square root of 99 9 times 11? Does 9 have a square root? It's 3. So what comes out here? 3. And what did I leave under there? 11. Now, again, if we can't remember that there's a perfect square that goes into 99, what do we do with 99? We break it down. 3 times 33, maybe you did. There's a break. 3 times 11. There's my group of 2. So out comes 3, and I left an 11 under there. Is everybody cool? Everybody remembers this from the 10th grade, right? Yeah? Okay. All of you do this page down to G, because it's all just numbers. You can do it any way you want. You can break it down into factories, or you can use perfect squares. I don't care which one you do. But you will notice, what are we not touching? Our calculator to find a square root, because these are all irrational numbers. Everybody cool? So let's go. Go. I'm just going to work on them up here. They're all on the screen. You can check your work. I'm not going to talk about it. I'm just going to go ahead and work. Okay? I know that I was an idiot. What a moron. The square root of 16 is 4, not 2. Stupid, stupid, stupid. No. I couldn't care less about my views, Sukhpal. We've gone over this. I am not doing this for me. I'm doing this for you people. As a matter of fact, the more views I get, that actually makes me a little bit sad because that means I didn't do a very good job of explaining it the first time. Oh, just because. Sometimes I need to screw stuff.
So you're screwed.
I'm screwed. Actually, the reason, I'll tell you, Jazz Carrot, my speakers don't work. So I use these screwdrivers to take them all apart to find out if it was something in the speakers, but it wasn't. It turns out it's the jack is busted. It's bent, and you guys probably don't know this, but you know that black part that goes around a headphone jack in that hole? That's actually where the sound comes out. There's two of them, one for the right speaker, one for the left speaker, one for the right earphone, one for the left earphone. If you have a mic on your earphones, you'll notice your headphone jack has three, because one of them is for the mic. But if you look closely at this, you will see that one of the black rings is gone, so I don't have a left speaker. So what I got to do is I'm going to cut this off, and my idiot children destroy headphones. I don't really know what they do to them, but like if they sit down on the car seat and there's some headphones under them, they'll start pulling, and then it'll get stuck under their ass because the earbud is stuck, and then they'll just keep pulling instead of lifting their butts up because they're little kids, and pull, 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 break. Oh, Dad, I broke the headphones. No kidding. So I got 1 million headphones sitting around my house that are busted up. Or they lose the little rubber things for the earbuds, and then I go to the dollar store and I buy them another pack for $1, and then they lose them too. And then when I'm cleaning the cat litter, right, you scoop up the cat poo, and in all the cat poo there's 1 million little earbuds because the cats eat them, right? So anyways, I got 1 million headphone jacks. So I'm going to cut this. I'm going to strip the wires. I'm going to bring one of my busted headphone jacks in here. I'm going to cut it. I'm going to strip the wires. Then I'm going to solder it all together. You know why? Because I'm a teacher, and ain't nobody cheaper than a teacher. Right? Why would I throw away this $100 speaker system for a 99-cent part? Only a crazy person would do that. And it's the people that throw away this because of a 99-cent part that are ruining our world. What? No. And even if there was a warranty on it, this is obviously something I did to it. It didn't come that way. I'm not a liar. Well, first of all, every time you buy something, you inspect it before you plug it in. No. Because I didn't get it new. This was thrown in the garbage in the office last year. And I was like, why are we throwing out this serious? Speakers are worth like hundreds of dollars. And I was like, I'll take it. And the office staff was like, I don't even know why it was here because I need speakers that work. So then I got it, I plugged into it, this year it didn't work. So then I looked at it, now I've sorted it out, now I'm going to fix it. I'm not going to throw it in the garbage. So it ends up in the North Pacific Gyre floating around for the rest of time because it's plastic, it's not going anywhere. Reduce, reuse, recycle. The 3 R's are still important. It's not like the stupid radio commercial with the raising your eyebrows and whatever it is now. All right. Civics lesson over. Back to math class. Other way around. Write as an entire radical. So, if there's a single 2 out here, how many 2's were under there? 2. So this is the square root of 5 times 2 squared, which is 5 times 4, which is root 20. Gouda? Great. Now here's a little hint for you. It's a little tidbit, little shortcut. Make your life a little easier. What is the index that should be written there? 2. What exponent did the factor get under the radical sign? 2. If it happens once in math, does it always happen? Yes. So that should be a 2, correct? So that means this is the square root of 29 times 7 to what power? 2, which is 29 to the 49th, which is a big number that I can't do in my head. So I'm going to rely on one of you to have done that with your calculator.
1421.
Thank you. Square root of 1,421. Because, of course, 1421 isn't a number, Yoon. That's a football score. 1,421 is a number. And we are in math class where we are concerned with numbers. 6 root 4? It's the same as 4 times what? 6 squared, which is 4 times 36, which is 144. Yay! Tricky. What's weird about 5? D. It's negative. Is it negative? Or is it negative 5 root 12? It's that, isn't it? So there's a 5 out here, so what was under there? Negative root 12 times 5 squared, which is negative 12 times 25, which is negative root 300. Yes?
For C, would you leave it at root 144 or would you change it to 12?
Well, I'm glad that you asked that, Max. I kind of paused a little there to see if anybody would say anything. Convert to a radical. So what would we leave it as? Right. What if I said simplify? 12. Okay? Well done, Max. Bonus point for you. Get enough bonus points, and maybe, who knows? All right. Without a calculator, put those in increasing order, which means littlest to biggest, right? It's really hard to do without a calculator unless you do what? What can you do to all of these to make it super easy to tell which is bigger and which is smaller? Convert them all to entire radicals, right? So that first one, if there's a single 7 out there, how many 7s were underneath? 2. So that is the square root of 98, right? Right? Okay. If there's a single 5 out there, how many were under there? 2. So that's the square root of 75, right? Then I had square root of 14. He's already in good shape. Then the number 9, which is square root of 81. Nice job, Yoon. And this last guy right here? Square root of 36. Now is it real easy to see what's the smallest and what's the biggest? What's the smallest? So root 14 would go first in our answer, wouldn't it? What's next? Root 36, which was 3 root 4. Then what's next?
5 root 3.
5 root 3, because it was root 75. Then
9.
9. Then 7 root 2. And that would be the right answer. Is everybody cool? The point of questions like that is to remind you that this particular value, 9, is also the square root of 81, which is also 3 squared, right? You are allowed to do anything you want to the numbers in math to make them work for you. Okay? Math does not work you. You work math. Okay? You can change stuff around, but you still got to follow rules. It's not like Harry Potter, right? It's not Accio calculator. Everybody cool? All right. So let's look at A there. What's different about it? It's a cube. So I'm looking for groups of what size? Groups of 3. Now I gave you a shortcut. If you knew the square roots, you could use them, couldn't you? So what can you do if it's a cube? You could use cube roots. So if you know a cube root that works with 54, you could do this question in about 1 second. But if you don't know your cube roots, you've got to break it down, don't you? Okay, so I know the cube root. Does anybody else? The cube root that goes into 27? No one? 3, yeah, because I just gave it away. The cube root that goes into 54. I said cube root that goes into 27, didn't I? What a moron. So I know that this is the cube root of 27 times 2, yes? What's the cube root of 27? 3, so it's 3 cube root 2. But let's pretend I didn't know that 27. What would I do with 54?
Just do it.
Break it down. 9 and 6, 3 and 3, 3 and 2. There's my group of 3. Out it comes. What did I leave in there? 2. Picking up what I'm putting down? Read my mail, mow my lawn? Sweet. So let's do 144. Do you know a cube root that goes into it? If you don't, are you in trouble? No, because you just break it down, right? 144 is 12 and 12, which is 3 and 4, which is 3 and 4. Stop, and then 2 and 2, and 2 and 2. So, I have the cube root of 2 to the 4th times 3 squared. I need groups of how big? 3. Do I have a group of 3 there? Where? 2. So I know a 2's coming out. How many 2's were left in there? 1. So I'm going to cross that out and write 1 because I took out 3 of them. Then what's left under there? 2 times 3 squared, right? What is 2 times 3 squared? 2 cube root 18. Cool? All right. So you guys go and do C through F. Meanwhile, I'll be working on them up here. If I have time, I'll do both ways. Okay? Is everybody okay with radicals? With any number for index? Everyone's good? Because that's still grade 10, right? So I'm going to shut up, but I want to make sure you guys are okay with one more thing. Just draw a G here. I want the cubed root of 54 x to the 5 y to the 7th. See if you can figure that one out. Would anybody like to volunteer their answer when they get it? You would like to volunteer your answer, you? I'm asking you.
I just can I just say the answer?
Just say the answer.
I don't know if it's right, but I just got 3xy squared cube root 2x squared y
2
x squared
x squared
y.
y. That is correct. Does everybody understand how to do that? Everybody? Okay. So, I'm going to go slow. Can everybody tell me how to do just that part, which I've highlighted in blue? Yeah? Okay. How? If I just gave you cubed root of 54, what would you do?
Break it down.
That's the cubed root of 27 times 2, yes?
Yeah.
Which would be the cubed root of 3 cubed times 2, right? There's my group of 3, so out comes a 3. Cube root 2. Is everybody okay to there? Okay. Now, highlighted in green, that is the cube root of x to the 5th, correct? Right? Okay. I'm looking at how big a group? 3. How many x's are under there? 5. So how many x's can I take out?
3.
One group of 3, yes? So out comes an x, and what did that leave under there? I took out 3 of them, so it left 2. Is everybody cool there? So there is my x squared and x. The yellow is the part you already knew. There it is. And then the last one is the cube root of y to the 7th. How many 3's get into 7? 2 of them, right? So I can bring out one y and another y. How many y's were left in there? If I took out 6, I left 1. Do we ever write y to the 1? No. Do we ever write y?
No.
What do we write?
Y squared.
Y squared cube root y. So I come back over here. There's my y squared. There's my y. Is everybody cool? Would you like to practice one more of those before I go further? All right, let's do one more. If you feel comfortable with radicals, go ahead and do page 31, 32. Stop at 33. If you feel you'd like one more practice, actually, I'll leave that on the screen so you can see it. And I'll write over here an H. Let's go with the fifth root of 64 x to the 12th, y to the 13th, z to the 4th. So you're either working on 31 to 33, or you're going to do that one first, which I'm going to show you the right answer for in a second. And everybody else is working. It is 10:11. You are in class until basically 11 a.m. That gives you 51 minutes to do 31, 32, and 33. That is more than you need. It was exactly enough work for one block, but because we got 15 or 20 minutes yesterday, it's a little bit too much class time for this assignment. The pictures kind of mess things up. So you're kind of getting a day off. Well, you kind of got 2 days off because you got yesterday off for pictures. So is it okay if I just do this one over here and then I'll explain it in a minute? Is everybody good? Okay, now I'm going to do one other thing here to show you what is happening in case you're still stuck, okay? But I don't want to work with this one because I made the exponents too big, all right? So I'm going to go back and I'm going to take this guy right here, okay? So here's what I'm going to do. No, I don't want to do it that way. I'm going to see if I can erase. Okay, this is what we had, yes? So if you don't understand what I've been doing with crossing out the exponents, then what did I say when we started exponents? If you don't remember the laws, if you write it out, then it's super easy in exponents. Radicals and exponents are pretty closely related, yes? So let's actually write this out. I need the cubed root of 27 times 2. Everyone's okay with that, right? Which is the cubed root of 3 cubed times 2. Everyone's okay with that, right? Which is the cubed root of 3 times 3 times 3 times 2. Everyone okay? Now, what is x to the 5 really? What is x to the 5th really if I write it out? What is it? No. X to the 5, if I write it out, is x, 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 x. Yes? And what's y to the 7th, really?
Y
Y, 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 Y.
Because.
How long were you waiting to say because, Yoon? From the second Y? All right, now, is everybody cool with what I've done here? Everybody understands this step here? Now, what does that index tell me? I need groups of 3, right? Is there a group of 3? So out comes a 3. Is there a group of 3? So out comes a single X. Is there a group of 3? So out comes a Y. Is there a group of 3? So out comes another Y. This is what comes out. 3 X, Y, Y. And what did I leave under there? The 2 X, X, Y. Now in math class, we would never write that. What do we write? 3xy squared cube root 2x squared y. Does everybody understand? This is what's really happening. The shortcut is groups of 3. I had x to the 5th, so I can fit one group of 3 with the remainder of 2. 7 y's, so I can get out 2 groups of y's with the remainder of 1. But we would never write 1 as an exponent. Is everybody good now? Is it all right to have to do this for practice? Yes. But you wouldn't want to do it with this question that I gave you over here, because you don't want to write x 12 times and then y 13 times and circle groups, do you? So that's why I gave you the little shortcut. How many groups of 5 can I get out? 2 groups of 5 x's with the remainder of 2. Cool? How many groups of 5 come out of here? 2 groups of 5 y's with the remainder of 3. Why did I have to leave z under there? Because I couldn't even get out 1 group of 5. Everybody okay? All right. Go. 31, 32, 33. I lied. 31. 31, 32, not 33. 31 and 32. That's what you're supposed to do. And then 33 is what we move on to tomorrow. No fighting. No fighting. No. So, 105 is the simplest thing, right? You take out a group of 14. Or a group of 2. Yeah, the answer is 14. Just like if it was square root of 4. That's the square root of 2 squared. That comes out to 2. There's nothing left out of it.
every time you break it off,
So I have
and
6
goes
root
3,
5. Yes.
7, 5.
Well, what was already up there? Negative 2/3. What do you do with all these things? What do we do here? Multiply. So it happens once on that. Does it always happen? What's negative 2/3 times 6? That's negative 12 over 3, which is negative 4 root 5. Okay? That's the point of questions like that. To see if you guys will yet believe me that you know how to do stuff. Just because it looks different doesn't mean anything different. Right? If I have numbers in front of the guys, I will plot them all together because they're all coefficients. So in this question, I put a number. So one. Okay? Anita. Okay, no, the 4 was already in there. It's not. 3 is
105 times 105 times 11 over 35. 11. That's it.
Yeah, but I know it's not
3 of them. 3 cubed is 27. Plus 2 is 27. Why don't you bring over a chair? Make something. All the way over there. I see. Soccer jacket? I know it's a Hilfiger jacket. But I'm making it again. You'd have to walk all the way over there and pick up the soccer chair. But I know you play soccer. Oh, silly me! Because basketball would be different. If it was soccer, I would understand because she couldn't pick up the chair. She'd have to like happy sack it over here. But basketball, let's see. Do you have that skill set? Use your hands, pick something up, and move it. I'm aware of that. Max, I am not putting down soccer. Okay? I've told you a million times. It's awesome cardio for rugby. The best rugby players started out as soccer players because they're super fit and understand how to move all around the field. I started out as a soccer player, and I'm not the best rugby player. But I did start out as a soccer player.
No, Mr. Myers. 31, 32. Do we stop at
98. 5 by 2.
You do 32, you stop 33.
5 by 2.
And that's probably going to take us to before the bell, so you're probably going to get some time off. Yo, that is a sassy calculator, man.
196.
Woo, doggy! Oh, I like it. Look at her colored lines.
Okay.
I cannot wait to graph some stuff from this. That's hot. Wait for it. You ask me a question. I'm gonna have some fun with this.
No, it's actually, you know what?
Exactly. So that's in its simplest form, isn't it?
It's just 14.
Okay. 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 I got it.
You just leave 15 like that? You just leave 15 like that? Just leave it.
14 is 2 times 7. What else? 7 times 2. And what else?
What?
The
Huh?
interview.
Oh, right, yeah. Oh, sorry, Cole.
You made me yawn.
What?
Step into my office.
Yeah. Yawning is a lie. Yawning is a lie.
No, it needs to be.
Broke down. And I got 5, 4 root 6.
Not asking you a question, I'm not asking you.
I know. Let's see if we can get it. Just let's see if we can get it. What?
Oh, Raphael. Beyond a shadow of a doubt.
Times 5.
5.
Equals 50.
The more I could do it better. He's introverted. It's time to get out.
This is 2. Then it is 3. Then it is 1.
Do it again. Oh, I think you're you just like yeah.
That's because I saw this. I thought it was Queen, not 4. Wait, stop. Stop, don't do that. Do the face, baby. You look like someone.
Someone that's so
Not ugly. He's a model.
highest of fives. No, the highest. There you go. The highest of fives. Good.
Yo, I am although. They already broke it.
S represents half the perimeter of the triangle. What's the perimeter? Try talking in here. Yes, you did. Very well. Yes. I know you're all worried. If that was a 3, and you put a bunch more numbers in front of it, what would you do with all those numbers in front of it? Okay. When you did. Guys, page 32, when there's a fraction in front of it,
Just multiply.
yes. If I gave you this question right here, as a matter of fact, we took, no, I don't want to do that. If I gave you this, the square root of 60, that is the square root of 4 times 15, yes? Okay, actually I'm going to do, I'm going to make that, that's not a good one either. Let's just use 72. Square root of 72 is 3 squared times 2 cubed, right? Right? So what comes out of there? Out comes a 3, out comes a 2, and I left a 3 under there, yeah? What did we do with the 3 and the 2? Yeah, you leave a 2, yeah. What do you do with the 3 and the 2? Multiply them together because they're coefficients, right? And you know that every number in front of the radical sign is a coefficient, yes? From our very first bit of notes on this, the A was a coefficient, right? And coefficients all multiply, yes? So what if there was already a 4 in front of this 72? 3, 2, and what was already there? A 4. What would you do with those 3 numbers? Multiply them together. So on page 32, you have a question that is negative 2/3 root 180. Well, out in front is a number. Fraction is just a number. So it's just a coefficient, right? So you're going to take this, you're going to simplify it, you're going to pull out all your coefficients, and then what are you going to do with all of them? Multiply them. Okay? Everybody good? Yes, of course. course.
Yeah?
Oh, yes. Julia, never, ever, ever change a way that you know how to do math because somebody does it a different way than you. Never. If they want you to, tell them to. Okay? If you know how to do something, do it. All right? Always. I will figure out what you are doing. Okay? Yes. No, Mrs. Bad Crumble is the name that my favorite comedian gives to his elementary school teachers because it just covers all of them. Cucamonga is a fake place. It's from Bugs Bunny cartoons. I think it's a fake place. I mean, there's some places in the world with really weird names. Oh crap! I've been recording all of that. What? 676 2 because it ends in 6. Huh? 13 squared. Now, just for fun, all right, so since that's 3 cubed, that's the cubed root of 4 times 3 cubed, which is the cubed root of 4 times 27, which is the cubed root of 108. That is the fourth root of 5 times 6 to the fourth, which is the fourth root of... I gotta get my calculator out, can't do that in my head. 6 to the fourth times 5. The fourth root of 6480. I'm actually going to get my calculator out and visible here. That is the cubed root of 7 times 5 cubed, which is the cubed root of 7 times 125, which is the cubed root of 700. 7 times 20 is 140. It's 840, 880. 7, that's not right, 125. 875. And my computer's frozen, so we'll just take a moment while we work it out. 875, there we go. This is already as simple as it gets because that's 7 times 5 times 3, no pairs, so it stays as 150. It stays at 105. This one, that is the square root of 14 squared, so it is 14. Third root of 432, so I got to take 432 and break it down. That is 2 times 216. I can stop there because I know that 216's cubed root is 6. So that is 6 cube root 2. This, I got to break it down. 375 and 10. So that's going to be 2 and 5 where I can stop. And 375 is going to break down. I know it's got another 5. So that's 73. 73 is a prime number. So I'm going to pull out. I got no pairs. or no sets. So am I done? No, of course I'm not done because it's not 73. 375 divided by 5. 75. 75. So then I break that down again to 3 and 25. Then I break that down to 5 and 5. So I've got the fourth root of 5 to the fourth times 2 times 3. Out comes the 5, fourth root 6.
No, clean it yourself.
384 is going to be the square root of 384. That is going to be 64 times, no, not 64. I'm going to break 384 down to 192 and 2. And then I'm going to break that down to 96. Then I'm going to break that down to 48. Yes.
Is 169 prime?
No, 169 is the perfect square of 13.
Oh, okay.
46. Then I break that down. Oh, sorry, 48. I'm going to break that down to 2 and 24. I'm going to break that down to 12 and 2. I'm going to break that down to 2 and 6. I'm going to break that down to 2 and 3. And then I'm going to see one group of 2, two groups of 2, three groups of 2. So out is going to come 2, 2, 2. And in there is going to stay a 2 and a 3. So it's 8 root 3, 6. And then over here, 180 is going to be 180 is going to break down to 10 and 18, 2 and 5, 2 and 9. I'm going to stop there because that's a square root. So out comes a 3, out comes a 2. There's already a negative 2 out there. So that's negative 2 times 2 is negative 4 times 3 is negative 12 root 5. You do know what S is. Read the question. What does S equal? Did you find it yet?
So, 80 plus 10 divided by 2. So it's 10.
So, you all know that formula. Here's another formula. The area equals this, where S represents the half perimeter. A, B, and C are the sides. Well, there's my A, B, and C. So A equals 8, B equals 10, C equals 12. Perimeter equals 30. So S equals 15. So now I simply go over here and I do this. S is 15. 15 minus 8, 7. 15 minus 10, 5. 15 minus 12, 3. And then all I got to do is break that down. 15 is 5 times 3 times 7 times 5 times 3. There's a pair, there's a pair. Out comes a 5, out comes a 3, and I left the 7 under there to get 15 root 7. But it's also 15 times 5 times 3 times 7. It's also the root of like 4,000 and something. Then I simplify each of these. So that is the root of 16 times 6, which is 4 root 6. That is the root of 2 times 121, so that's 11 root 2. That, we already know that is 12 root 5 from the page right before. So out comes a 12, and I had negative 2/3 out there. Then I had root 180. 12 times negative 2/3 is, it wasn't 12, sorry. It was 6 times negative 2/3. So that's negative 4 root 180. 320 is 16 times 20, which is 16 times 4 times 5. Square root of 16 is 4. Square root of 4 is 2. And I had a 1/8 out there, leaving a 5 underneath. 4 times 2 is 8. 8 times 1/8 is 1. So that is root 5.
Mr. Meyer,
Yo.
doesn't she should be minus 4 root 5?
Oh, yeah, not 180. Yeah.
Yeah, it just
Yeah.
makes
I just forgot to, yeah. So then these have to be broken down. So if I break that down with 5, that's going to be 49. I can stop there because 49 is a square root. 7 root 5. Break 338 down. 2, I break it down into 169. That's a perfect square, so it's 13 root 2. 1250 is 125 times 10, which is 5 cubed times 2 times 5. There's 4 5s, so out comes 2 5s. 25 root 2. 66. 6 times 11. 2 times 3 times 11. No groups. It's already done. 304 is 2 and 152. 2 and 76. 2 and 38. 2 and 19. There's a group of 2. There's a group of 2. So out comes 4 times negative 5, 6 is negative 20 over 6 root 19. And I can leave it that way, or I can tidy it up by reducing that. 980. 98 times 10. 2 times 49 times 2 times 5. Out comes 7, out comes 2, 14 root 5. Bye, guys. Well, not quite. Bye. 272 is 1, 2, and 136, which is 2 and 63, which is 9 and 7. And I can stop there. Out comes a 2, out comes a 3. There was already a 4. I left root 7. So that's 24 root 7. Do some highlighting. 288 is 144 times 2. Out comes a 12, negative 36 root 2. Maybe it'll show up in a second. There it is. So guys, all the right answers are on YouTube. That is 9 times 41. Out comes the 3, 6 root 41. That is that's going to be 4 times 91. It's going to be 2 root 91. 450 is 45 times 10, which is 9 times 5 times 5 times 2. 9 has a square root of 3. Out comes a 3. Out comes a 5. There's 2 fifths out there already. I left a 2 under there. 3 times 5 times 2 is 30 over 5, so that is 6 root 2.
Bye, Sue.
Bye. And then 341 is 7. No, not 7. Oops. Bye. Yes. Yep. 11 times 31. No pairs because they're both prime. So that guy is done.